Hey everybody. So in this video we're going to be going through the exercise that we asked in the previous document, and that is to derive the Pythagorean theorem by comparing two different measurements for the area of this diagram. We want to relate the area of the big square equal to the length times the width, which would be a plus b times a plus b. To show that that is equal to the area of the little square, which would be c squared, plus the area of each of the four triangles, which are all congruent. So each of them have side of a plus b and a hypotenuse of c. Okay, so how are we going to do this? Well, we look at the area of the big square to be the length times the width of that big square, which we see to be a plus b as the length and also a plus b as the width. And then the area of the little square is going to be almost like the tilted square on the interior of the big square, and that's going to have a length and a width of c, so the length times the width will be c times c. We want to add to that the area of the four triangles, where the area of each triangle is going to be 1/2 the base times the height. So we're going to want 4 times the area of one triangle, which is going to be 1/2 the base, which is going to be a, times the height, which is going to be b. And we want to show that these two equations are indeed equal. Right? And it makes sense because we're looking at the area of the big square with a length of a plus b to be equal to the area of the little square, which is the c squared, in addition to each of the four triangles to complete the area of the big square. Okay. So in order to work this out, we just need to do some algebra. So with a plus b times a plus b, we'll use the generalized distributive property. We'll say that this is going to be a squared plus ab plus ba plus b squared. And it's going to be equal to c squared plus 4 times 1/2 is 2ab. Okay. So if you notice here, we get a squared plus ab plus ba, that's going to be plus 2ab, so our multiplication is commutative in this case. And it's going to be plus a b squared on the left side, and this should be equal to c squared plus 2ab on the right side. Okay. If you notice, both of these have a 2ab in them, so it'd be nice to subtract that so we can get rid of that in a sense, make it a bit nicer, and voila, we come out to see that the derivation here supplies us with the Pythagorean theorem, where we get a squared plus b squared is c squared.